there are different parabolic structures. Some of them are bridges, lens, dish antenna. If you see this particular bridge diagram, it's nothing but a curve or a conic section, and there are multiple coordinates here that we need to remember. So first point is, say, focal point. We have focal point here, and then there is vertex. Vertex is nothing but where the two curves of the parabola meet. Then there is a perpendicular line that moves across the vertex, which is called as the tangent. In this particular parabola, this tangent is nothing but the x-axis. And the perpendicular, this particular line in which there is focus point, is called as the axis. In this parabola, this axis is nothing but y-axis. If you see, if you draw a perpendicular from this focus point and extend on both the sides so that it touches the parabola, then that particular line is called as latus rectum. So the main characteristic of a parabola is, if you measure from any point in this parabola to the focal point, that distance, that is, say we have a focal point here, and let's consider any of the points on this parabola. The distance from this focal point to this point is same as the distance from this parabolic point to directrix. So directrix is always opposite to the vertex, and focal point is always inside the parabola. So there are multiple uses of this parabolic functions and coordinates. Say for example, in the construction of bridges, we have to lay these cables. So how do we know the height of each of these cables? So these coordinates and the equations help us in finding us the focal point and the lengths of these cables. Say for example, we have to lay the foundations underwater. In such cases also we would need to know the depth of the cables. So the equation of parabola, the focal point, axis, the vertex, the tangent, all of these parameters do help us in finding out the depth, the length, the distance, the height, etc. So there are 4 types of parabolas based on where the parabola opens up. The first one is the parabola on the right hand side. If you see, this falls under the first quadrant where x and y are both positive. So this is called as the right hand side parabola. Here if you see, the axis on which the focus is there is called as the axis, and it's nothing but x-axis. Similarly, if you come to the second type of parabola, which is left hand side parabola, here the opening is on the left hand side and it's on the second quadrant and third quadrant. That is why you see that it's on the negative. The x-axis here is negative, and axis is nothing but the line that passes through the focus, right? So in this case, the axis is x-axis. Now the third type of parabola is upward parabola, because the opening is on the upward side. Now if you look at the quadrant here, it's again on the first quadrant and second quadrant, right? And the axis is y-axis, because the focus is inside the parabola, which is in the y-axis. The fourth type of parabola is downward parabola. In this case, it's the same as the third type, but it falls within third and fourth quadrant. That is the bottom quadrant where x and y are negative. Here again the axis, which is lying on the focus, is y-axis, and the tangent is here x-axis. The tangent is nothing but the line that passes through the vertex. So the equations of each of these parabolas are given here. For the right hand side parabola, we have y square is equal to 4ax. For left hand side, it is y square is equal to minus 4ax. Same equation as the type 1, only difference is that it is minus 4ax. Reason being, it's on the negative side of the quadrant. X is on the negative side here. The third type, the equation for third type of quadrant, which is the upward parabola, is x square is equal to 4ay. Right? It's similar to this equation, but the x and y are swapped. And the fourth type of parabola, which is the downward parabola, the equation is same as the type 3, but you have a negative sign because the parabola is opening in the bottom side of the quadrant where both x and y are negative. So that's why we have minus 4ay here. we have four kinds of parabolas and we will have to determine all the characteristics of these parabolas. So we have multiple characteristics. One is the equation, focus, axis, directrix, latus rectum coordinates, latus rectum length. Let's figure out how to remember these characteristics and how to arrive at them. Because we have four kinds, it's difficult to remember all four equations and all four characteristics. Let's find a shortcut. Right, so let's plot four parabolas here. Let's put, for the first one, this is the right hand side parabola. Let's put focus on the x-axis on the first quadrant. Right, so, and for the second one, we'll put focus on the second quadrant. Third one, we will have focus on the y-axis. And fourth one is again in the negative side of y-axis. Now, first thing that we need to determine is focus. Right? What is the focus coordinate? In the first type of parabola, which is right hand side parabola, what is the coordinate of this? It is of the form a, 0. Why a? Let's assume that the distance from the focal point to the vertex, let's consider this vertex of the parabola, is a. So, it is a here. And what is the y coordinate? It is 0 because it's directly lying on the x-axis. For the second parabola, focus is on the second quadrant where x is negative. And we assume that the distance from the focal point to the vertex of the parabola is minus a. So what is the coordinate? It's minus a and 0 because it's directly on the x-axis. Now let's draw this parabola here. So we know the focus. Let's write the focus. Focus here for the first one is a, 0. And for the second one, which is left hand side parabola, it is minus a, 0. So we know the focus. Now, what's the axis? Axis, here the focus point. The axis in which the focus point lies is the actual axis. So here the focus point is lying on x-axis. So axis is x. Here also it's the same case, it's x. Let's arrive at directrix, right? We know directrix is opposite side of vertex. So if the vertex is here, the directrix would be on the opposite side. So where does it fall? It falls on the negative side of the x-axis. And we know the distance from focal point to vertex is a. So this will be minus a. So directrix here would be minus a. Let's come to the second type. For this left hand side parabola, directrix would be on the opposite side, which is now on the positive side of the x-axis. So here the distance is minus a from focal point to vertex. From vertex to the directrix would be plus a. So directrix is plus a. Now let's come to the LR coordinates. LR coordinates is nothing but latus rectum coordinates. Latus rectum is the perpendicular that passes through the focal point and touches the other two sides of the parabola. Right? So this is LR. Now what is the coordinates of LR? So LR coordinates are of the form a, 2a. In the sense, one side is a, which is nothing but the distance between the focal point to the vertex, and the other side is 2 times of the distance. So what is the coordinate of the other side? This is a, 2a. The other side also would be the same thing, right? A, 2a only, but with a sign difference. Now, where will we put a negative sign here? Because the other side is on the negative side here. So, x is positive, it's y that is negative. So, y is minus 2a. So, this is the LR coordinates. What is the LR length? It is by formula or by derivation, LR length is 4 times of a. So, which is 4a. Right? In both the cases, it will be 4a. Now let's arrive at the equation of the parabola. Let's remember the first equation. for the right hand side parabola, let's remember this. Y square is equal to 4ax. Right? If you remember this equation, we can infer or derive the equations for the remaining three. Right? The technique is, if this is y square is equal to 4ax, for the parabola which is on the left hand side, it will be exactly the same thing with a small difference, which is minus. Now, how do we remember this as minus? Because a is minus here, right? This is minus a, and it's on the x-axis. So, this way we can remember the equation. Now, let's go to the third and fourth type of parabola, which is upward parabola and downward parabola. Let's do the same thing first. Let's arrive at focus. Focus is here, focus is on the y-axis for upward parabola and downward parabola. So, since focus is on y, the y coordinate would say it's a, and the x coordinate, there's no x coordinate here, so it's 0. And the focus for this particular parabola would be same 0 and a, but it will be minus a because it's on the negative side of y-axis. Right? So, we have focus, which is, in this case it is 0 and a, and in this case it is 0 and minus a. Now, what's the axis? Axis would be, where is the focus lying on? Y-axis. So, it's simple. It's y-axis. What is the directrix? Directrix is the opposite side of the vertex. So, this is where we have directrix. Now, we know this distance is a. So, obviously, this distance is going to be minus a. So, this is going to be minus a. And for this parabola, it's going to be opposite of this, which is less a. The directrix is going to be here. Now, you see, directrix is on the upper quadrant. So, it's positive y. So, it is a plus a. This is minus a. Now, what is the LR coordinates? Right? Again, LR coordinates is of the form a to a. Now, here we have x coordinate is 0. So, the technique is x coordinate is 0, which means that will be 2 times of a, and the other one would be as it is, a itself. So, here also it would be 2a and a. Now we need to determine the signs. What will be the sign for LR coordinate? This is the LR coordinate. So, this will be, we know it will be 2a, comma a, and here also it will be 2a, comma a. So, what will be the sign? 2a would be, this is the x-axis, x is on the negative side, right? So, it will be minus 2a and y is positive, so a. And here x is positive, 2a, y is also positive, so a. So, this will be minus 2a. Now, let's come to the LR coordinates of fourth type, right? Here, this will be the LR coordinates. So, again this will be of the form 2a and a, 2a and a. Now, what will be the signs? Here x coordinate is minus, so it will be minus 2a, and y coordinate is also minus, so it's minus a. Here x coordinate is plus, so it will be plus 2a. Here y coordinate is minus because it's the negative side of the y-axis, so this will be minus a. So, let's write it down here. So, we have the LR coordinates. LR length is going to be 4a for all 4 cases. Now, coming to the equation. The technique here is, take the first equation, which is y square is equal to 4x, and swap x and y. So, we get x square is equal to 4ay. And for the fourth type, it's the same thing, but there will be negative here because we have negative a here, minus a, and it's on the y-axis. So, this is how we can try to remember the parabola characteristics. Let's find the equation of parabola given vertex as 0, 0, axis as y-axis, passing through a coordinate half and 2. Now, the first clue is y-axis. The focal point is on the y-axis. So somewhere here we have y-axis. It passes through half and 2, which means the parabola passes through the first quadrant. So somewhere here we have half and 2. Say this is our x and y. This is our focal point. Now what is the equation for upward parabola? It is x square is equal to 4ay. We don't know what a is. We can use this coordinate as x and y. Substitute x and y and get a. X is half the whole square is equal to 4 into a into y, which is 2. So we get 8a as 1 by 4, which is a is equal to 1 by 32. Now let's substitute a in this equation 1. We get x square is equal to 4 into 1 by 32 into y. So x square is equal to 1 by 8 into y, which is nothing but 8x square is equal to y. 8x square minus y is equal to 0.
Let us take another example where vertex is 0, 0, axis is y and passes through coordinates -1 and -3. Axis is y, which means focal point is on y-axis. Say this is f. Now the coordinates are -1 and -3. That is x and y are negative, which means it falls in the third quadrant, somewhere here. So this is a downward parabola. So what is the equation for downward parabola? It is x square is equal to minus 4ay. Why minus here? Because the coordinate is lying on the negative side. Let's take the coordinate given here, -1, -3 as x and y. Let's substitute x and y in this equation so that we get a. -1 the whole square is equal to -4 into a into y, which is -3. So we get 12a. So a is equal to 1 by 12. Let's substitute this in the above equation. So x square is equal to -4 into 1 by 12 into y, which is x square is equal to -1 by 3 into y. So we get 3x square is equal to minus y. So we take minus y to the other side. We get 3x square plus y is equal to 0. This is the equation of the parabola.